Welcome back. In this video, we will solve the puzzle Tower of Hanoi and develop algorithm, pseudocode and flowchart for the same. Tower of Hanoi is a mathematical game or puzzle that was invented by the French mathematician Edward Lucas in 1883. Tower of Hanoi puzzle generally consists of 3 towers. The towers may also called as pegs or rods and can have more than one disc of different sizes which can slide onto any tower. The number of discs and sometimes tower may vary. The puzzle starts with the disc placed in any tower in an ascending order. That is, the smaller one sits over the larger one, thus making a conical shape. The objective of the puzzle is to move the entire disc to another tower without violating the sequence of arrangement. Initially, the tower where the discs are placed are called as source, and where it finally moved are called destination. The other tower will be called as auxiliary or spare. There are few rules to be followed for Tower of Hanoi during the movement of disc. The puzzle should be solved on obeying the following simple rules. Rule number 1. Only one disc can be moved at a time. Rule number 2. Each move consists of taking the upper disc from one of the stack and placing it on the another stack. That is, a disc can only be moved if it's an uppermost disc on a stack. Rule number 3. No disc may be placed on top of a smaller disc. Now, let's uncover the puzzle Tower of Hanoi. To write an algorithm for Tower of Hanoi, first we need to learn how to solve this problem with lesser amount of disc. So here we are going to take 2 discs and 3 towers. We mark 3 towers with the names source, destination and auxiliary, or otherwise called as aux. Here the aux tower will be used only to help moving the disc. If we have only one disc, then it will be easy to be moved from source to destination. In this example, we have taken 2 discs. To move both the disc from source to destination, first we have to move the smaller disc to the aux tower. Then we move the larger disc to the destination tower, and finally we move the smaller disc from aux to destination tower. These 3 steps will be used to move 2 discs from one tower to another tower. Now let's solve the same puzzle using 3 discs. Here in the figure you can notice we have 3 towers A, B and C and 3 discs which is placed in tower A, which is in source. And our goal is to move all the 3 discs from tower A to tower C. So I am keeping the tower C as a destination and I am going to use the tower B as an aux. I am going to mention the disc as large, medium and small. Here goes the first step. I am moving the small one to the tower C. Next, I am moving the medium to the tower B, followed by I am taking again the small disc from tower C to the tower B. Until now you would have noticed we have not violated any of the rules. So here the next move is from tower A to tower C. I have moved the large disc from tower A to tower C. And then I am just taking the small disc and placing it in the tower A, and medium to the tower C, and finally I am just moving the small disc from tower A to tower C. So finally we have moved all the discs from source to destination. With 3 discs, the minimal number of moves required to solve a Tower of Hanoi puzzle is 2 to the power of n minus 1, where n represents the number of discs. That a puzzle with 3 discs has taken 2 to the power of 3 minus 1, where we will get 7 as a result. So you can see we have taken 7 steps to solve this puzzle. Hope you understood the moves that are being taken to solve this puzzle. Next, we have to find the logic behind this so that can be written in an algorithm or pseudocode or flowchart, which can further be converted into any programming language needed. So the approach here is we have to take the upper 2 discs from source and move it to the aux. You can see the 2 discs from tower A has been moved to the tower B. We know how to move 2 discs from one tower to another tower. So apply the same logic here. So the step 1, move n-1 discs from source to aux. Step 2, move the larger disk from source tower to the destination tower. That is, move nth disk from source to destination. Next, I have to move the 2 discs from tower B to tower C. Repeat the same step that we have used to move 2 discs from tower A to tower B. Now you can see we have moved the 2 discs from tower B to tower C. That is, the third step is move n-1 discs from aux to destination. So to put it consolidated, the main algorithm here is step 1, move n-1 disc from source to aux, and then step 2, move nth disc, that is the biggest disc, from source to the destination, and finally step 3, we have to move the remaining n-1 disc from aux to destination. Finally, we have assembled all the discs in the destination tower. To develop this logic in an algorithm or a pseudocode, we have to know the concept recursion. Recursion is calling the same action from that action, just like shown in the picture, where you see the same picture within the other one. It's looped within itself again and again. This is called recursion. Or say another example where you are dreaming. In that dream you had another dream. In that you had another dream, and it goes on. So if you want to come out of it, you have to come out from the innermost dream one by one. So if you want to do the same kind of action, you can use the recursion concept. When a function or a module calls itself again and again, it's called recursion. Recursion is useful in problem solving, which can be broken down into a smaller task of its same kind. But there is one main thing you have to take care of it. That is, you have to specify the limit at a particular point and come out of it. So keep in mind, there is one rule for doing any recursive work. You must be giving a condition to stop that action executing. Otherwise, it will be keep on looping for an infinite number of times. We are going to apply this recursion concept in our puzzle, where we are performing the same type of moves again and again. Let's see the complete logic structure. I have mentioned the logic in pseudocode. Initially, start, then I have developed the procedure called Hanoi. So Hanoi can be called as a procedure or function or module, which does a specific task. Here, our task is to move the disk among the towers. So we are going to implement the recursion concept. This function Hanoi will be called whenever I want to perform same kind of task. You can see I have received input into the function. So the first parameter is, that is the first input is disk, second source, that is the source tower, then destination as a third parameter or the third input value, and finally the aux tower, which I am going to use it temporarily to perform the moves. So first I will be checking if disk is only 1. If so, then I will move the disk from source to destination. So when we solve the puzzle with 3 disks, when we will have the remaining 1 disk only at the 6th stage, where only the small disk has to be moved to the destination tower. So I can end the procedure if I have moved the one particular disk or the last disk of the move. Say if not, I am having the disk more than 1 to solve the puzzle. So here I am going to give else, where I am going to put all the 3 steps that we have framed earlier. You can see I have given the step 1 within the else. So I am going to perform the same step again and again. So I am calling the Hanoi function, where I am passing the 4 parameters. Here the disk will be disk minus 1. So you can see in the step we have to move n-1 disk from source to aux. So that's why I have given disk minus 1, and the source here is the same. Whereas here in this particular step the destination is aux tower. That's why I have given the third parameter as aux, and finally I have given destination tower at the end, which I will be using as an temporary tower to make the move. In the figure you can notice at the end of the first step the upper two discs from tower A has been moved to tower B, that is from the source to the aux. Next I have brought the step 2 into the procedure where I have moved the nth disc from the source to destination. So here n represents the disc, so move disc from source to destination. Again the third step where I have to perform n minus 1 disc from aux to destination. That is, in the diagram you can see the two discs from tower B has to be moved to the tower C. Here tower B acts as an source and tower C is an destination. So when you see within the procedure, the first parameter to the function is disk minus 1 and next I have given aux. That is because I am going to take the tower B which is an aux tower. So that is where my two discs are there. I am going to use that as a source and where I am going to move to it to the destination tower, and finally the source has to be mentioned at the last, which I am going to use it for temporary move. At the end of this step 3, I would have moved all the discs to the destination tower. So finally I am ending it and ending the procedure and stopping the pseudocode. Here you can see the algorithm and pseudocode for Tower of Hanoi puzzle. You know the difference between the algorithm and pseudocode. So algorithm has to be given as step-by-step procedure. You have to mention step 1, step 2, and for this particular puzzle we have mentioned totally 8 steps to solve it. Similarly, if you are developing it in a pseudocode, you have to give all the keywords in caps. You can see all the keywords here, start, if, else, everything has been given in capital letter, and we have used proper indentation while implementing the blocks. Similarly, you can see the flowchart for this puzzle where I have given the function at the start and I have checking for whether the disk is 1. If so, I can just move the final move from source to destination, I can end it. Else, I have to perform recursion where I have to call the same function again and again. You would have noticed the symbol what I have used to implement to call the function is predefined process. So the symbol name is predefined process symbol. So finally I am ending up the flowchart. That is, I am ending up the function Hanoi. From this video I hope you can now understand the Tower of Hanoi puzzle and how to solve it with the help of recursion concept. Also we have seen its algorithm, pseudocode and flowchart which can be further utilized by the programmers to implement the logic. Here I am sharing a link. In this page you can see the animation of the puzzle and also play yourself to solve the Tower of Hanoi problem. Thank you.